Hey guys, welcome back in. Mr. Marone here. We are in section 7.5, the last section in our similar triangles, or our similarity section. And so we're going to be living with proportions again. There's two sets of these that are going to bring in proportions again, which is great because they're not very difficult math-wise. So let's hope that this continues on the way the other sections have. So the first one we're going to look at is something called the side splitter theorem. And it says that if I have a parallel line like RS is compared to XY, so if RS is parallel to XY, that gives us this setup. It divides the sides of the triangle proportionally. Or in other words, this becomes a proportion where the top two segments, QR, that's not a Q, QR and QS are going to be equivalent to RX and SY. So what I'm going to do as well is I'm going to switch colors here because there's an equivalent fraction to this. I compared the top left to the top right and then the bottom left to the bottom right. The other thing you could do is compare it and actually treat it like it's a proportion. Draw in your line there, and it could be QR over RX, and that equals QS over SY. Those are equivalent fractions. I'm going to take the time now just to showcase this for you. If I go back to my red and I cross multiply here, I have QR times SY equals QS times RX, whatever those measures are. If I then switch to my blue again and I cross multiply again, I have QR times SY equals QS times RX. So either way I set it up, I end up with the same equation, which is good. That means they're equivalent. So you can either compare the top left to the bottom left and the top right to the bottom right, like we did in blue, or compare the tops and then compare the bottoms, as long as you do the same side, both fractions, meaning you do all left or all right as first. So we're going to take a look at two examples of this. I'm going to do the first one with you, and then I'm going to let you do the second one. So in the first one, using the side splitter theorem, I've got my top 12 over my bottom x plus 1, and that equals my top 9 over my bottom x. And you literally could just draw in our proportion lines, and you've got it all set up already. And then you just have to cross multiply. So I've got 12x equals 9 times the quantity x plus 1, or 9x plus 9. I'm multiplying 9 times both of those. And then doing my algebra, I have 3x equals 9, so x equals 3. Go ahead and try the second one. The one thing I want you to see is the whole right side is 33. So that means this piece here is only 22, based on that piece being 11. So keep that in mind when you do these problems. Go ahead and try this, and when you come back in, the answer will be there for you. All right, welcome back in. So once again, as you can see here, I drew in my little proportion line there so that it was already set up for me. X over x plus 12 equals 11 over 22. And when you cross multiply and solve out, you end up with x equals 12. Now, we do have what's called a corollary, or just an addition to this theorem. And this tells me that if three parallel lines intersect two transversals, so the picture you have here, then we end up with a lot of proportional sides here, and it creates proportionality here. So if line A is parallel to line B, which is parallel to line C, in other words, all three are parallel, then we end up with a proportion here of this piece over this piece, so AB and WX, and then I've got this piece, BC, over this and this piece, XY. And once again, just like we did up top, you could set it up where you put, this piece over this piece and then BC over XY, or you can keep it set up just like that. So if we think back to drawing in our little proportion bar here, here, and put my equal sign there, it's the same setup. So looking at my examples here, I could do that here. I can draw in my proportion setup, and I've got 2 over 7 equals 3 over x. And then just cross multiply. And you have 2x equals 21, so x equals 10.5. go ahead and try our second one there, and when you come back in, answer will be there. All right, welcome back in. So setting up my proportion, once again, I drew in my bars and all of that, and I have 2x plus 2 over 10.5 equals 8 over x. Cross multiplying, I end up getting an x squared, so I'm going to have to factor. I moved everything so that everything was on one side of the equal sign, and I had all three terms divisible by 2. So I divided out by 2 on each side to remove that 2. And I ended up with x squared plus x minus 42. So two things that multiply to negative 42 and add to a positive 1 would be 7 and negative 6. And then simplifying out, I got that x equaled negative 7 and positive 6, and we can't have a negative measure, so 6 is our only possible answer there. So the last piece of this is what's called our triangle angle bisector theorem. And this is if I have an array that bisects an angle of a triangle, then it divides the triangles into two segments that are proportional. In other words, it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So if in my picture ray AD bisects angle CAB, we end up with the left side, this line CD, this left piece of the opposite side, over the left-hand side of the triangle itself, CA, is congruent to the right-hand side of the opposite side, DB, over the right-hand side of the triangle, AB. So I end up with a proportion there. And once again, looking at our two pictures here, you just draw in your proportion bars and your equal sign. You have 10 over 12 equals 18 over x. And over here, you've got y over 9.6 equals 24 over 16. And just solving those out, you end up very quickly finding the answers here. 10x equals 216, so x equals 21.6. And then cross multiplying here, 9.6 times 24 is going to give me 230.4 equals 16y. And when I divide that by 16, I end up with y equaling 14.4. So it's really just a couple ways to get ourselves into proportions. And then once we're in proportions, it's cross multiplying and solving, just like we've been doing. So right there is our all of our rules for this, for both side splitter theorem and your triangle angle bisector theorem. If you have any questions, be sure to ask me, and you can move on to the practice. Have a great day, guys. Bye-bye.